So in this video, I'm going to provide solution to the MOKASA joint examination, March-April 2019, Physics Paper 1. And let's go straight to the first question. Section A, the first question. In the first question, we are asked to define free fall. Now, free fall is a type of motion whereby an object is moving under the influence of gravitational pull only. This object could be falling through air, meaning that there is air resistance, or it could be falling through vacuum, meaning that there is no air resistance. So generally, there are two types of free fall. One where there is air resistance, and another one where there is no air resistance. But because we have been asked to define free fall, then we just need to state that it is a type of motion where the object is falling or it is moving under the influence of gravitational pull or gravitational force. Over here, of course, I've run short of space. It's because my handwriting is quite large. So in an examination situation, always ensure that you estimate how much space maybe your writing will take so that you don't run out of space. But however, that one is not a very big problem. Now let's go to question 2. In this question, we are told that the figure below shows a force of 40 newtons acting on a body of mass 4 kilograms. The coefficient of friction between the surfaces is 0.05, and the diagram is given here, and then you are told to determine the acceleration of the object. Acceleration. Now, when you are asked to determine the acceleration of an object, of course, this is a moving object, you need to check carefully if there are any forces which are acting on the object. If there are forces which are acting on the object, chances are that you must use dynamics. And dynamics is the study of motion under the influence of forces. If forces have not been mentioned, then we are talking about kinematics. This is a type of motion where we look at a moving object, but we don't need to consider the forces which are acting on the object. So here, of course, I've been given that there is a certain amount of force of 40 newtons. We can call it the pull, or let's give it the letter P, pull of 40 newtons. It could be, maybe this one is a block of wood, and then there is a rope tied to the wood, and then somebody is pulling. So this is an external force which is acting on this object. The other force which is acting on this object is frictional force. In other words, this surface tends to apply a force on this object which tends to resist its motion. So that force must be acting in the opposite direction to the direction in which the object tends to move. And we are going to call it frictional force. I'm going to use the letter F with subscript R to represent frictional force. Remember, friction force in this case tends to prevent this object from moving in this direction, as is the nature of friction all the time. The other type of force that is acting on this object is, of course, its own weight, mg. And the weight, W, is given by mg, where m is the mass of the object in kilograms. This is the gravitational pull or the gravitational field strength, which is 10 newton per kilogram. And when we multiply 4 kilograms by 10 newton per kilogram, we get 40 newtons. Of course, you realize that this kilogram and this kilogram are going to cancel out, and you're left with the unit newtons. So the weight of the object is 40 newtons. It appears to be equal to the pull, but don't worry about that. This one is just by coincidence. This force may have had any other magnitude, 50 newtons, 30 newtons, and so forth. So don't draw any conclusions here that the pull is always equal to the weight. That is not the case. It just happens to be equal to the pull at this particular point. Of course, there is another force which is acting on this object, and it is exerted by this surface vertically upwards. We usually refer to this force as the normal reaction. We are going to give it the letter R. And in this case, it is equal to W. And W is 40 newtons. Now, the reason R is equal to W is because in this direction, the object does not have any acceleration. The object is not accelerating in a direction which is perpendicular to the surface. It is accelerating horizontally. So, because the acceleration vertically upwards or vertically downwards is 0, then the resultant force in this direction is 0. This further means that opposite forces must be equal. So if you know one of them, you should know the other one. That is how I end up concluding that the normal reaction is 40 newtons. So there are two forces which are acting on this object, and they are exerted on this object by the surface. And one of them is the frictional component, the other one is the normal component. In fact, those are their actual terms: frictional component of the contact force and the normal component of the contact force. But generally, we usually talk about the normal reaction and frictional force. Now that we have shown all the forces which are acting on the object, we need to calculate the acceleration. First of all, let's calculate this frictional force. When an object is in motion, friction force is usually given by the coefficient of friction mu times the normal component of the contact force. So this will be 0.05 times 40 newtons. And this will be this actually is going to be equal to 5 over 100. I just want to verify that it's actually equal to 2 newtons. And you can see this and that. Of course, this will give me 20 over 10, and this gives me 2 newtons. I just need to show you all the steps so that you end up understanding what I am doing. But you could have calculated this one very fast just using a calculator. Just in case you want to see how I work it out, then I take my time to show you this. And then we want to calculate the acceleration. When an object is accelerating, there must be a resultant force in the direction of the acceleration. So we state Newton's second law, which states that resultant force is equals to ma. This is a very important equation, and you should understand that this F is usually the resultant force. It's a vector, and it produces the acceleration on an object of mass m, and that acceleration must be in the direction of the force. Very important. So, if we know the direction of the acceleration, which is in this case, it is in this direction, then we conclude that there is a resultant force in the same direction, because the acceleration must be in the direction of the resultant force. Now, in Form 1, we were given situations where we have an object with the two forces. One of them is acting in this direction. The other one is trying to oppose that motion. And in order to get the resultant force, you always subtract the smaller one from the bigger one, and the resultant force will be in the direction of the bigger force. For example, if this is 100 newtons and this is just 20 newtons, then you end up saying that the resultant force will be equal to the bigger force, which is 100 newtons, minus the smaller force, which is 20 newtons, and this gives me 80 newtons. The direction of this resultant force is to the right. It always points in the direction of the bigger force. Similarly, we can use that concept over here when we resolve these forces horizontally. And you find that the resultant force is actually P minus frictional component of the contact force is equals to MA. P is 40. Frictional force is 2. M is 4. And it is A that we want. So this will give us 38 is equals to 4A. And this implies that our A is equal to 38 over 4. Let's do some division here. By 2, get 2 here. By 2, I get 19. By 2, I get 9 because of 18. Remainder 1. 1 divided by 2 is 0.5. So the acceleration is going to be equal to 9.5 meters per second squared, and it is to the right. And this is how you would work out a question like this. Let's move over to question 3. Now, in question 3, we are told that we have a uniform bar. Uniform bar. I'll be explaining the significance of that. A uniform bar is pivoted at a point 30 centimeters from one end. A force of 12 newtons at the end of the shorter side keeps the bar in equilibrium. If the length of the bar is 1 meter, determine the weight W of the bar. In order to solve this type of question, you need a sketch. So we are told that we have this bar. So I'm going to draw a straight bar and try to make it as uniform as possible. Like that. And it is 1 meter. That is 100 centimeters. So from here all the way to here is 100 centimeters. Now let's go to this point here. It is a uniform bar. This word here tells us that the position of its center of gravity is at its geometrical center. In other words, if I take 1 meter, I divide it by 2, I will get 0.5 meters. That means that this center of gravity is 0.5 from either end. This is 0.5 and this is 0.5. So the uniform bar or the word uniform is mentioned because the examiner wants you to identify the position of its center of gravity. Once you have identified the position of its center of gravity, you should know that it is through that point that the actual weight of the object acts. By definition, center of gravity is the point through which the weight of the object acts. So we have identified its position, and this is W. Now, the other pieces of information are that it is pivoted at the 30 centimeter from one end. So let's assume from here to here is 50 centimeters. So 30 centimeters is somewhere around here. That is where the bar is pivoted. So we put our pivot there. So from here all the way to where the pivot is 30 centimeters. 30 centimeters is like 0.3 meters. And those who have a problem with how I have identified this, I just need to say that or to remember that 100 centimeters is equivalent to 1 meter. So how about 30 centimeters? And you find that for you to convert centimeters into meters, we just need to divide by 100. So we do a bit of cross multiplication here. Now, from here to here is 50 centimeters. That means the rest of the distance here is 20 centimeters. And 20 centimeters is 0.2 meters. Now, let's see. A force of 12 newtons at the end of the shorter side. See, this is the shorter side. It is 30 centimeters. This is the longer side. It is 70 centimeters. So, we put a force of 12 newtons at the end or at the edge of the bar at this point because it is a shorter side like we have been instructed there. 12 newtons. That's it. Remember now, everything now is falling into place. We are asked to determine the weight of the bar. Of course, this system is about equilibrium, mechanical equilibrium. And when we are talking about mechanical equilibrium, there are two conditions which apply. One of them is that resultant moment is 0. That means that sum of clockwise moments is equal to sum of anti-clockwise moment. The other condition is that resultant force is 0. What that means is that the sum of forces in one direction will be equal to the sum of the forces in the opposite direction. For instance, at this point, there is a force which is exerted on this bar by the pivot upwards, and we can call it R. And through the same point, there is a force exerted by the bar on the pivot, which we can call P. Of course, the other force which acts on the bar is this one and this one here. We are interested in the forces acting on this bar. Very important. Forces acting on the bar. What are they? It is this one, and this one. Now, in order to calculate the unknown, we need to apply one of those conditions of equilibrium. And the best one is the sum of the clockwise moments about a point is equal to the sum of the anti-clockwise moments about the same point. Now, I need to identify the point about which to take moments. It's always very important to identify that point clearly, because if you don't do that, you might end up with forces, unknown forces in your calculation, and they make your calculation to be a bit of a problem. So over here, I will be very careful to choose a point where unknown forces, which are not required in the calculation, are eliminated. And I would choose the pivot. So I will say, take moment about the pivot. By doing that, I'm sure force P and force R will be eliminated because their lines of action pass through the point about which I'm taking moments. Their moments about that point is 0. Then, the 12 Newton force will of course tend to turn the system in the anti-clockwise direction, while the W will tend to turn the system in the clockwise direction. So this is anti-clockwise and this is clockwise. Of course, you will remember using the idea that this system tends to turn in the direction in which the arm of the clock moves, and that is why it is called clockwise. There's supposed to be a W there. Clockwise moment, anti-clockwise moment. So I'll put this equal sign and I will start with sum of anti-clockwise clockwise moment is equals to sum of clockwise moment. And of course, the reason why I've started with the anti-clockwise moment is because I have the anti-clockwise moment on this side. I want this equation to be exactly where the pivot is. Because this one is a very simple question, it can be solved that way. So, remember I'm talking about sum of anti-clockwise moment. But over here, we've only got one anti-clockwise moment, which makes our problem even easier. The other point is I've already identified the point about which to take moments is this point. So all distances are measured from this point. The distance from this point all the way to the line of action of the 12 Newton force is 0.3 meters. That distance must always make 90 degrees with the line of action of the force. And of course, in this question, it is making that angle. It's perpendicular to the line of action of the 12 Newton force. So I'm going to say 12 Newton force times 0.3 is equal to the clockwise moment, which is due to W, which is a type of force, times how far it is from there, and this is 0.2. So 12 times 0.3, I divide both sides by 0.2. That 0.2 comes here, and I'm getting W. And this implies that W will be equal to 12 times 3 divided by 2. I have multiplied here by 10 and here by 10 in order to get rid of the decimal. And you can see I've got very simple numbers to deal with. So over here, divide by 2. Here, divide by 2, I get 6. And this gives me 18 newtons. And that is the weight of the object. Now let's look at question 4. So over here, I had to zoom out so that the whole question can be seen. Now, in this question, we are told that a student observed some pollen grains on the surface of water in a beaker with the help of a hand lens as shown in figure below. So there is a hand lens, there is a transparent lid, and there is some pollen grains, and of course this is water in a beaker. Now, state the observation. Now, this type of, this question tests our understanding of Brownian motion. This is Brownian motion in water. So the type of observation which is made here is that the pollen grains are observed to move randomly. They are agitated. They move in a zigzag manner. They are not at rest. They are sort of restless. So we describe that type of motion as the fact that they are moving randomly. The observation is that the pollen grains are moving about randomly. So, remember we are using the hand lens to magnify the pollen grains so that we can be able to see them clearly. Now explain the observation in A above. The pollen grains are moving randomly because they are being bombarded by the lighter invisible particles of water. It's because they are being hit by the invisible particles of water. Let me explain this term. To bombard is to hit something randomly without any particular pattern. So the pollen grains, if this one is a pollen grain, it's observed to move in this direction, in this direction, in this direction, in that direction. So it's moving about randomly. If a particular pollen grain is observed, this is the way it will be moving. It's not possible to predict its motion. That's why the word random has been used. And because we are observing something which is moving randomly, then we conclude that whatever is striking it is also moving randomly. This is why we make this conclusion that water is made up of particles which are in continuous random motion. That is the kind of conclusion we make here. I've run out of space in which to write, but in an examination situation, you might want to control the size of your handwriting so that it fits very well in the space where you are writing. Okay, water is made up of particles which are in constant random motion. And that is how you would answer that question. Now let's tackle question number 5, where we are given that an immersion heater consumes a voltage of 240 volts and a current of 10 amperes. If it is used to heat 5 kilograms of water at 20 degrees Celsius, find the final temperature of water after 7 minutes. And you're given that the specific heat capacity of water is 4,200 joules per kilogram per Kelvin. So this question is on quantity of heat. There is electrical energy which is being converted into heat energy. So we can say that electrical energy is actually converted into heat energy. So you can say heat energy, of course, through this transducer, which is an immersion heater. An immersion heater is the transducer which converts electrical energy into heat energy. Now, electrical energy will be given by the power of the heater times the time through which the heater is on. So this one will be equal to the heat energy absorbed by the water, which will be equal to mc delta theta. The power of the heater is current times voltage, of course, times the time, because we are talking about electrical energy, is equal to mc delta theta. And we want to calculate the final temperature of the water. Now, the current here is 10, voltage 240, the time is 7 minutes. We must convert these 7 minutes into seconds by multiplying by 60. It is equal to, the mass of this water is 5 kilograms. Its specific capacity is 4,200. And the change in temperature will be, let's assume that its final temperature will be theta. So the rise in temperature will be theta minus the initial temperature, which was 20. So remember, that is how we get this delta theta, or change in temperature. Let's see how this one turns out to be. So we are going to say that theta minus 20 is going to be equal to, for here I think I need a calculator. I need to multiply 240. You have got 2,400, because it is 240 times 10 times 7 times 60 is 420, because 7 times 6 is 42, divide by 5 times 4,200, and this will give me, at this point we can use the calculator. 2,400 times 420 this will give me 1,008,000 divide by half 5 times 4200. This will be 21,000. So I have 1,008,000 divide by the answer. We are going to get 48. This will be 48. So this is theta minus 20 is equals to 48. It means that theta is equal to 48. I can subtract 20 from, I can add 20 to both sides, in which case this will disappear from this side. Or I can take minus 20 across the equal sign, in which case it will become positive 20. And I get 68 degrees Celsius. And this is the final temperature of the water after 7 minutes.